Optimal solution is nothing but the maximum value or minimum value of a function. The points within and on the boundary of the feasible region represents the feasible solution of the given linear programming problem. Maximum value 180 at 2 points. What are the 2 points? 0, 20 and 15, 15. So this is how we are going to solve a linear programming problem graphically. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, lecturer in mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding very important chapter, that is LPP, linear programming problem. In this chapter you will get one 6 marks question from part E, the linear programming. So the weightage for this is, so you may get a definition. I will explain what are the definitions we are going to study in this linear programming in part E. So this is the weightage, 1 mark 1 question and 6 marks 1 question. Totally you will get a 7 mark. Actually this linear programming problem is one part, one chapter in operational research. There is one subject called operational research. In that we come across one small unit, that is the linear programming problem. So there are different types to solve the linear programming. In your syllabus you are going to study only the graphical method. So formation of a linear programming problem and solution of a linear programming problem using graphical method. There are different methods like simplex method, big M method, a two-phase method, but you are going to study only graphical method. Actually this subject was developed during the Second World War to study, to analyze the problems in war field. Now that is actually the war is concerned, but here the linear programming problem we are using to get the maximum profit with the what are the sources, limited sources available. Using limited sources available to get the maximum profit, we are using the concept of a linear programming problem. Now let us discuss regarding the definition. What are the definition we come across this linear programming problem? So in this session we are going to study only the solution of a linear programming problem using graphical method. Another one is the formation of a linear programming problem and the solution by graphical method. Now let us come to the definition. What is the definition of a linear programming problem? So a linear programming problem is one that concerned with finding the optimal solution. Optimal solution is nothing but the maximum value or minimum value of a function. To get the maximum or minimum value of a function, a linear programming problem is that concerned with the finding the optimal value, means finding the minimum value or maximum value of a linear function of several variables. Variables may be x, y. X and y are the decision variable we are using here. So a linear programming problem is one that concerned with optimization to get the optimal value, optimal solution, that is maximum or minimum value of a linear function of several variables. Now what is linear objective function? The linear objective functions, or it is also called as the decision variables, we are going to take as x and y. Any equation of the form, a function, a linear function, z is equal to ax plus by, where a and b are constants and x and y are the decision variables, has to be maximized or minimized, is called the linear objective function. So a function of the form z is equal to ax plus by, where a and b are constant, x and y are the decision variables, is to be maximized or minimized, is called the linear objective function. The objective function is z is equal to ax plus by, which is to be maximized, max z or minimum z. This is equal to ax plus by. This is called the objective function, that is called the linear objective function. Now let us come to the next, feasible region. Feasible region, the common region determined by all the constraints including non-negative constraint. Non-negative constraints means x is greater than or equal to 0 and y is greater than or equal to 0 of a linear programming problem is called a feasible region. That is the common region determined by all the constraints. Suppose if this is the graph, x-axis, y-axis, you are going to get a region like this, then this is called the feasible region. This is called the feasible region. That is the common region determined by all the constraints including non-negative constraints. X is greater than or equal to 0 and y is greater than or equal to 0 is called the feasible region. Usually the feasible region, suppose if the inequality, if it is greater than or equal to 0, the feasible region is always towards the origin. It is towards the origin. If the inequality less than or equal to for greater than or equal to the feasible region is towards the origin. If it is less than or equal to, the feasible region is, that is, away from the origin. That is very important concept. So a common region determined by all the constraints including the non-negative constraints, x is greater than or equal to 0 and y is greater than or equal to 0 is called the feasible region. If in a given equation, if the inequality is greater than or equal to 0, the feasible region is away from the origin. Less than or equal to 0, then it is towards the origin. That is very important point. Now feasible solution, the points within and on the boundary of the feasible region, the points within and on the boundary of the feasible region represents the feasible solution. The points, this is very important point, the points within and on the boundary of the feasible region represents the feasible solution of the given linear programming problem. Now the next definition is optimal solution. This is also a feasible solution. The optimal solution means any point in the feasible region that gives the optimal value, that is maximum value or minimum value of the objective function is called the optimal solution. That is any point in the feasible region which will give the maximum or minimum value. Any point in the feasible region that gives the optimal value. Optimal value is nothing but the maximum or minimum value of the objective function is called the optimal solution. Optimal solution, this is very important definition. Next, what is the meaning of constraint? The definition of a constraint: a linear inequalities or equations or restrictions on the variables of LPP are called the constraints. Usually the constraints are x is greater than or equal to 0, y is greater than or equal to 0, or the non-negative constraints. So the linear inequalities or equations or restrictions on the variables of a linear programming problem. The restrictions or linear inequalities or the equations on the variables of a linear programming problem are called the constraints, and the non-negative constraints we are come across this is x is greater than or equal to 0 and y is greater than or equal to 0 are called the non-negative constraints. Okay, these are few definitions. So definitely you will get one definition from this 6 for 1 mark. So let me see what are the definitions. So that is definition. First, the definition of a linear programming problem. A linear programming problem is one that is concerned with the finding the optimal value, that is the maximum or minimum value of a given linear function of several variables. Now linear objective function, any equation of a form z is equal to ax plus by, where a and b are constants which is to be maximized or minimized is called as the linear objective function. Here x and y are called the decision variables. Sometimes we can also write the equations in the form of max z or minimum z is equal to x1 plus x2 in the form of the linear decision variables x1 and x2. Now next, feasible region, the common region determined by all the constants. This is very important definition for 1 mark. Feasible region, the common region determined by all the constants including the non-negative restrictions. X is greater than or equal to 0, y is greater than or equal to 0 of a linear programming problem is called the feasible region. The common region, this is very important point. The common region determined by all the constraints. Suppose if the inequality is greater than or equal to 0, then the feasible region is away from the origin, and if it is less than or equal to 0, it is towards the origin. That is very important concept. Now, the feasible solution, the points within and on the boundary of the feasible region, the points within and on the boundary of the feasible region represents the feasible solution of the given constraints. Now, the optimal solution means any point in the feasible region that gives the optimal value. Optimal value means the maximum or minimum value of the objective function is called as the optimal solution. Next, and the linear inequalities or equations or restrictions on the variables are called constraints. That is, the non-negative restrictions, non-negative constraints are x is greater than or equal to 0 and y is greater than or equal to 0. So these are few definitions. And now let us discuss regarding the solution of a linear programming problem first. Then we will discuss regarding the formation and the solution of a linear programming problem. Now the first one is the solution by graphical method. So in the examination you will get one question for 6 marks in 40 like this. Solve the following linear programming problem graphically. Now what is the procedure to solve a linear programming problem graphically is just convert the given linear inequalities less than or equal to or greater than or equal to into an equation equal to. Convert less than or equal to or greater than or equal to into the linear equation equal to, and represent and solve these equations and represent the points in a graph sheet. Now usually you might have been studied the equation of a line in the form x by a plus y by b is equal to 1. This is nothing but an intercept form of a straight line. What is the x-intercept? What is this? X is nothing. A is the x-intercept. A is the x-intercept and b is the y-intercept. If I draw a graph for this, the equation is like this. This is origin 0, 0. This is a. This is x-intercept is a. And the point B is 0, B. This is y-intercept is B. Okay. Now this equation is of the form x by a plus y by b is equal to 1. What is a here? A is nothing but the coordinates of x-axis here, x and y here. So OA is equal to x-intercept. Therefore the coordinates of A is a, 0. And OB is called the y-intercept. The coordinates of B is equal to 0, B. Therefore, convert this equation in this form. For that, we are going to take the value of x one time as 0 and the value of y one time as 0. Now, to solve this equation, take x is equal to 0 and y is equal to 0. You will get these 2 points, point A and point B. Represent these points in a graph sheet and draw a straight line and find out the feasible region and the corner points and solve. That's it. Okay. Now let us come to the problem. What is the problem given? This is very important problem. Solve the following linear programming graphically. What is the intention? The objective function is maximize z is equal to 4x plus y, max z, maximum of z. So the objective function is to be maximized. Subjected to the constraints. What are the constraints? X plus y is less than or equal to 50, x plus y is less than or equal to 50, 3x plus y is less than or equal to 90, and the non-negative restrictions, x is greater than or equal to 0 and y is greater than or equal to 0. So maximum z is equal to 4x plus y, subjected to the constraints. These are the constraints. Now let us convert these constraints in inequalities into the equation form equal to. So this can be written as x plus y is less than or equal to 50 can be written as x plus y is equal to 50, and this equation 3x plus y is less than or equal to 90 can be written as 3x plus y is equal to 90. Now solve this, find out the values of A and B coordinates. Now put x is equal to 0. If you put x is equal to 0, 0 plus y is equal to 50, y is equal to 50. Therefore, the coordinates of A is equal to x is 0, y is 50, 0, 50. Similarly, put y is equal to 0. Then you will get x plus 0 is equal to 50, x is equal to 50, Therefore, the coordinates of B is equal to 50, 0. So, that is why this is called the x coordinate. X, the A value is 0, 50, and the Y coordinate we are going to get 50, 0. Now, similarly, find out the points for this equation. Put x is equal to 0. We will get y is equal to 90. Therefore, the coordinates of C is equal to 0, 90. Again, put y is equal to 0. You will get 3x is equal to 90. X is equal to 90 divided by 3 is equal to 30. Therefore, the coordinates of D is equal to 30, 0. So, thus we got A, B, C, D, the coordinates for the two lines. For the equation, x plus y is equal to 50 for the first line, and 3x plus y is equal to 90 for the second line. We are going to get two coordinates A, B, C and D. Represent this in a graph sheet by taking a suitable scale on x and y axis. That's all. Okay. I will draw the graph. What are the points? A, B, C, D. What is A? We got A 0, 50, 0, 50, B 50, 0. What is C? C is 0, 30, 0, 90. D 30, 0. Okay. Now let us represent this in a graph sheet. Now let us consider the suitable scale. Now the scale, consider a scale. Here the maximum value is 90. 1 unit is equal to 10. So 1 unit is equal to 10. That means 1 centimeter is equal to 10 units, or 1 centimeter is equal to 10 unit on x-axis and y-axis. Okay. Let us represent this as origin 0, 0. Each unit is equal to 10 centimeters. So maximum we will get, let me represent this as 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. This is the x-axis. X-axis. On the y-axis, let us represent this as y-axis. Again same 10, 20, 30, 40, 50, 60, 70, 80 and 90. Okay. Now, what is the first point? A 0, 10. Let us take A. What is A? 0, 50. 0, x is 0, y is 50, 10, 20, 30, 40, 50. This is A. 0, 50. Right. Now B. What is B? B 50, 0. X is 50. X axis 10, 20, 30, 40, 50, 0. This is B. 50, 0. Now let us draw a straight line. So join these two by drawing a straight line. Now what is this equation? This is for the equation x plus y is less than or equal to 50. X plus y is less than or equal to 50. This is, I'll write here, x plus y is less than or equal to. Less than or equal to means, since it is less than or equal to, therefore the feasible region is towards the origin. Towards the origin. See here, this is 50. Again 50, less than or equal to 50 means the feasible region comes in the downwards direction. Towards the origin, downwards direction. Now let us come to the second part. What is C? C is equal to 0, 90. X is 0, y is 90. This is C. C, x is 0, y is 90. Then D. D 30, 0. X is 30. This is 30 and y is equal to, x is 30, y is equal to 0. This is D. 30, 0. X is 30, y is 0, and the point C, x is 0 and y is 90. Now let us join this. If we join this, again you will going to get a straight line like this. Now, since what is the equation here? This equation is again, this is nothing but 3x plus y less than 90. 3x plus y less than or equal to 90. Less than or equal to 90 means the feasible region is towards the origin, towards the downwards direction. So the feasible region where it will join, here it is. The feasible region is towards this direction. So for this is the feasible region. For this also, this is the feasible region. So therefore, I can shade this. Now, actually, this is the feasible region. So this is called the feasible region. Feasible region. Now, what are the corner points? Now, this just find out the value of this E. This is E. Find out E where it will cut the x-axis and y-axis. So this will cut the x-axis and y-axis at this point. X-axis at 2 and y-axis as 30. So by drawing a suitable graph, you are going to get this point E. Now what are the corner points? Therefore the corner points are O 0, 0, O, then A, what is A? 0, 50, and again it is E 20, 30, then D. Actually where it is? It comes here D is equal to 30, 0. These are the corner points. Okay. Now I will show this graph again in the NEET sketch. Usually the feasible region is like that. Now you got an idea. Now the graph is like this. See, this is the exact graph. So what are the corner points? Therefore the corner points are O 0, 0, and again A is equal to 0, 50, and again E is equal to 20, 30, and D is equal to 30, 0. See here, exactly this will cut x-axis at 20 and y-axis. This is the region where it will cut the x-axis at 20 and y-axis. So if you draw the sketch, you will get x-axis as 20 and y-axis as 30. Therefore, E is equal to 20, 30. Now, find out what is to be required to find is the maximization. So, what is given? Max Z is equal to, what is the objective function? The objective function is maximum Z is equal to 4x plus 5. Now, corner points. Corner points here, maximum value. Now, at, what are the corner points? At 0, 0, what you will get? Z is equal to 0 plus 0 is equal to 0. At second point 0, 50. At 0, 50, you will get Z is equal to 4 into 0 plus 50. This is equal to 50. Again, at second point 20, 30. At 20, 30, what you will get? Z is equal to 4 into 20 plus y is 30. This is 80 plus 30 is equal to 110. Now at last point 30, 0. At 30, 0, you will get Z is equal to, that is 4 into 30 plus 0, that is equal to 120. Now let us form a table like this. Now what is the maximum value here? The maximum value is 120. This is maximum. So the maximum value is 120. So the maximum value is 120 at 30, 0. So this is the maximum value. So let us write like this. The maximum value is 120 at 30, 0. Therefore, the maximum value, maximum is equal to 130. 120 at 120 at 30, 0. So this is the solution. The maximum value is 120 at the point 30, 0. This is how, this is the procedure, this is the method to solve a linear programming problem using graphical method. Hope you followed this. Okay. Now, let us come to the next problem. Let me take another problem. Let us come to the next problem. Solve the following linear programming problem graphically. Maximize z. Objective function is to maximize subjected to the constraints. What are the constraints given? X plus 2y is greater than or equal to 10. 3x plus 4y is less than or equal to 24. X is greater than or equal to 0 and y is greater than or equal to 0. Non-negative restrictions. Now, so let us convert these inequalities into equalities. So this can be written as x plus 2y is equal to 10, first equation, first line, and the second line 3x plus 4y less than or equal to 24 can be written as equal to 24. The first step is convert the inequalities into equalities, that is equal to, less than or greater than equal to can be written as equal to. Now put x is equal to 0. If you put x is equal to 0, then you will get 2y is equal to 10. Y is equal to 10 by 2 is 5. Therefore, the first point A is equal to 0, 5. Again put y is equal to 0. If you put y is equal to 0, you will get x is equal to 10. Therefore, the second point B is equal to 10, 0. This is B. Similarly, for the second equation, put x is equal to 0. If you put x is equal to 0, 4y is equal to 24. Y is equal to 24 by 4. This is equal to 6. So, therefore, the point C is equal to 0, 6. 6 4s are 24. Again, put y is equal to 0. You will get 3x is equal to 24. X is equal to 24 by 3. This is nothing but 8. So, therefore, the other point is D is equal to 8, 0. These are the points A, B, C, D. Okay. Now, listen to me. Let us convert the inequalities into equalities. Equal to x plus 2y is equal to 10. Put x is equal to 0. You will get y value as 5. The first point A is equal to 0, 5. And put y is equal to 0. You will get x is equal to 10. So, therefore, the B is equal to 10, 0. Similarly, for the second equation, put x is equal to 0. You will get y is equal to 24 by 4 as 6. Therefore, C is equal to 0, 6. And put y is equal to 0. You will get x is equal to 24 by 3. That is 8. Therefore, the value of D is equal to 8, 0. Okay. Now, let us represent this in a graph sheet. I will go to the next page. What are the points? What is A? What is B? What is C? And what is D? A is equal to 0, 5. B 10, 0. What is C? C is 0, 6. 0, 6 and D is equal to 8, 0. Now, let us consider a suitable scale. Scale 1 unit is equal to 1 centimeter. 1 centimeter is equal to 1 unit on x-axis, and y-axis. So, let us consider on x and y-axis 1 centimeter is equal to 1 unit. Now, let us represent this as, now, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is x-axis. On the y-axis, again it is 1. Here 1 it is 2, 3, 4, 5, 6, 7, 8, then 9 and 10. Now, let us come to the first point. What is A? A 0, 5. X is 0, y is 5. 1, 2, 3, 4, 5. This is A. 0, 5. Now, what is B? B 10, 0. X is 10. 1, 2, 3, 4, 5, 6, 10. This is 10, 0. So, this is B. 10, 0. Okay. Now, draw a line. So, what you will get? A straight line like this. This is the straight line. This is nothing but, I will write the equation. What is the equation we have? First equation is x plus 2y is greater than or equal to 0. Greater than or equal to 10. Greater than or equal to 10 means, as I told in the beginning, if it is greater than or equal to means the feasible region is away from the origin. It will goes upward direction. Okay. So here this is 10, here C it is 10. So the feasible region is away. It will goes in this direction. So the equation x plus 2y is greater than or equal to x plus 2y is greater than or equal to 10. Now let us come to the next point. What is the next point? C 0 comma 6. X is 0, y is 6. 1, 2, 3, 4, 5, 6. This is C. What is C? C. I'll write C here itself. C 0 comma 6. And the last point is D 8 comma 0. X is 8, y is 0. X is 8, y is 0. Now draw a line. Now what is the condition? What is the curve given here? 3x plus 4y is less than or equal to 24. 3x plus 4y. So the curve is 3x plus 4y is less than or equal to 24. Less than or equal to means the feasible region is towards the origin. So like this. So here for this, see, this is in this direction, this is the downwards direction. So we are going to get this as the feasible solution. What is the feasible region we are going to get? This is the feasible region. So this is the point where it will cuts. This is the point E. Now find what is E here. Actually in the graph sheet, if you write exactly in the graph sheet, so you are going to get the point at this E. So if you represent this exactly in a graph sheet, so definitely it will cut the x-axis at 4 and y-axis at 3. So the point E is equal to 4 comma 3. Okay, this is the feasible region. This is the feasible region. Okay. Now what are the corner points? Therefore the corner points are, here the corner points are A 0 comma 5 and C 0 comma 6 and E 4 comma 3 are the corner points. That's it. Okay. Hope you followed this. Now I'll go to the next page. Therefore the corner points are O 0 comma 0, that is 0 itself. What is the first point? A 0 comma 5, then C 0 comma 6 and E. What is E? E is equal to 4 comma 3. These are the corner points. Okay. Now I'll go to the next page. What is to determine? The objective function is max z is equal to 200x plus 500y, 200x plus 500y. Corner points. What are the corner points? Zero comma 0, A 0 comma 5, C 0 comma 6 and E 4 comma 3. Now, so therefore substitute here corner points and z is equal to 200x plus 500y. So at O 0 comma 0, z is equal to 0. At A, what is A? 0 comma 5, z is equal to 200 into 0 plus 500 into 5. So this is 500 into 5 is 2500. Next, at second point C 0 comma 6, at 0 comma 6 z is equal to 0 plus 500 into 6, this is equal to 3000. Again at E, what is E? 4 comma 3. At 4 comma 3 z is equal to 200 into 4 plus 500 into 3. What is this equal to? 2 4s are 8, 800 plus 5 3s are 15, 1500. This is nothing but 2300. This is 2300. So at 0 comma 0, z is 0. At 0 comma 5, z is equal to 2500. At 0 comma 6, z is equal to 3000. At e 4 comma 3, z is equal to 2300. Now what is the maximum value here? So the maximum value, what is required to find is the maximum value. So therefore the maximum value is 3000. This is maximum. So I can write this as the maximum. This is the required solution. Maximum. Therefore maximum value is 3000 at 0 comma 6. At 0 comma 6. Suppose if you want to find the minimum value, means minimum is 2300. This is minimum. So minimum value is equal to how much? 2300 at what is the value? E 4 comma 3. 4 comma 3. That's it. So the maximum is 3000 at 0 comma 6 and minimum is 2300 at 4 comma 3. So if they ask find the maximum value, show the maximum value. If it is minimum value, represent the minimum value. That's it. Hope you followed how to solve this. Now let us come to the next problem. Solve the following linear programming problem graphically. Minimize and maximize. Here both the conditions are given. So you have to find out the minimum value as well as the maximum value. Okay, what is the objective function? Minimize or maximize z is equal to 3x plus 9y. Subjected to the constraints. What are the constraints? X plus 3y is less than or equal to 60. X plus y is greater than or equal to 10. X is less than or equal to y. X is greater than or equal to 0 and y is greater than or equal to 0. So here there are three equations. X plus 3y is less than or equal to 60. X plus y is greater than or equal to 10. And x is less than or equal to y. There are three equations are given. Now let us convert these inequalities into the equalities. Now the first equation is x plus 3y is less than or equal to 60 can be written as x plus y is equal to 60. Put x is equal to 0. You will get 3y is equal to 60. Y is equal to 60 by 3. This is nothing but 20. So therefore the value a is equal to 0 comma 20 is the first point. Again put y is equal to 0. You will get x is equal to 60. Therefore the point b is equal to 60 comma 0. This is b. Now again for the second equation, what is the second inequality? X plus y is greater than or equal to 10 can be written as equal to 10. Put x is equal to 0. You will get y is equal to 10. Therefore c is equal to 0 comma 10. Similarly put y is equal to 0. You will get x is equal to 10. Therefore d is equal to 10 comma 0. Now what is the another equation? X is less than or equal to y means x is equal to y. Y is equal to x. Now you know y is equal to x is nothing but an equation of a straight line which passes through the origin. So you can take equal values. See here what are the points we have obtained? That is 10 comma 10, 20 comma 20, 30 comma 30. So you can take when x is equal to 5, x is equal to 5, y is also equal to 5. When x is equal to 10, y is equal to 10. When x is equal to 15, y is also equal to 15. Okay. Now let us consider any 2 points. Now let us take E is equal to, therefore one point A, B, C, D, E is equal to, consider 5 comma 5 and F is equal to 15 comma 15. Let us choose these 2 points. X is equal to y, y is equal to x means x is equal to minus. So if x is 5 means y is also 5. If x is 15 means y is also equal to 15. So these are the points. Now let us represent this in a graph sheet. Now I will go to the next page. What are the points I will take here? Now therefore A is equal to, what is A? 0 comma 20. What is B? B is equal to 60 comma 0. Now next AB. What is C? C is equal to C 0 comma 10, 0 comma 10 and D is equal to 10 comma 0. What is E? E is equal to 5 comma 5 and F is equal to 15 comma 15. So these are the corner points. Now let us represent this in a graph sheet. Let us take a suitable scale. Scale in x-axis and y-axis. 1 centimeter is equal to 5 units. Let us consider 1 centimeter is equal to 5 units. Okay. Now let us call it as this is 0, then 5, 10, 15, 20, 25, 30, 35, 40, 45 and 50. This is y-axis. On the x-axis maximum we have 60. X-axis this is 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 and 60. You will get, let us assume it as 60. Okay. Now the first point A, 0, 20. X is 0, y is 20. So it is here A. I will write here 0, 20. B, what is B? 60, 0. It is B. 60, 0. Now draw a line. This is a straight line. Straight line. So what is the equation? X plus 3y is less than or equal to 60. X plus 3y less than or equal to 60 means the feasible region is in the downwards direction. Okay. Now second, next C. What is C? 0, 10. X is 0, y is 10. This is C. 0, 10 point C. And D. What is D? D is also 10, 0. This is 10, 0. So you will get a line like this. Now what is this line? X plus y is greater than or equal to 10. That means this is x plus y greater than or equal to 10 means the feasible region is away from the origin. It will goes in the upward direction. Now what is the third point? E is equal to 5, 5. X is 5 and y is 5. And F, this is E. 5, 5. And F, what is F? 15, 15. So what is, where it is 15? Here it is 15. So 15, 15. Okay. Now what is the condition? Just draw a straight line. This is a straight line. A straight line which passes through the origin. Now what is the condition here? X is less than or equal to y. X is less than or equal to y. That is, x is equal to y or y is equal to x. So therefore this is the feasible region. The region is this. Alright. The shaded region, the feasible region is, this is the feasible region. So this is the feasible region. What are the corner points then? The corner points are this C 0, 10 and A 0, 20, then F 15, 15 and E 5, 5. So these are the, this is the feasible region. And the corner points, substitute and get the maximum and minimum value. That's it. Hope you followed this. Now, so therefore the corner points are A 0, 20, A, then A, I will come to C 0, A, C, E, what is E? 5, 5 and F, what is F? 15, 15. These are the corner points. Okay, I'll go to the next page. What is the objective function? Minimize or maximize Z is equal to 3x plus 9y. So Z is equal to 3x plus 9y. Now corner points at, what are the points we have? At A 0, 20 and then C 0, 10 and E 5, 5, then F 15, 15. Now let us find out Z. Z is equal to 3x plus 9y. What we are going to get here? This is equal to 3 into 0. This implies 3 into 0 plus 9 into 20. This is 180. Next, for C, this implies 3 into 0 plus 9 into 10. That's equal to 90. For this implies 3 into 15, 3 into 5, 3 into 5 plus 9 into 5. What is this equal to? 5 3s are 15 plus 9 5s are 45. This is equal to 60. What is the last one? 3 into 15 plus 9 into 15. What is this equal to? 15 3s are 45 plus 15 into 9. 15 into 9 is 135. So that is equal to 135 plus 15. This is equal to 180. 180. These are the values. Now, which is the minimum value here? The minimum value is 60. This is the minimum value. So, therefore, minimum value is 60 at, what are the points? 5, 5. At 5, 5, it is minimum. Maximum. What are the maximum? There are two maximum values. See, this is one maximum value. This is also another maximum. There are two maximum values. This is one maximum and this is one maximum. This is minimum value. There are two maximum values. So, therefore, the maximum value is 180 at, there are 2 points. One is at 0, 20 and another one is 15, 15. So, this function has one minimum value 60 at 5, 5 and two maximum values. Maximum value 180 at 2 points. What are the 2 points? 0, 20 and 15, 15. So, this is how we are going to solve a linear programming problem graphically. Hope you followed this. Okay. That's regarding the definition and solution. How to solve a linear programming problem graphical method. So that is regarding today's session. So in the next session I am going to discuss few more problems. Thank you very much.